Assalamu alaikum. Welcome to this online lecture series of data mining. In our previous lectures on the topic of association rule mining, we had discussed about the different frequent pattern mining algorithms, including a priori algorithm and frequent pattern growth algorithm or FP growth algorithm. We had also discussed several extensions and improvements in the a priori algorithm, including ECLAT as well as partitioning method and DHP, which is known as direct hashing and pruning method. So in this lecture I'm going to demonstrate you the actual working of these algorithms on different well-known data mining tools, and in this lecture I'll use Weka and RapidMiner data mining tools for demonstrating the working of the association rule mining algorithms. So first we'll work on Weka algorithm, which is an open source data mining tool. So this can be easily downloaded from this URL. So just click on this URL and it will open up your default browser. And it will take you to the web page of the Weka. From here you can browse to the download and install tab. Just click on it and it will ask you to select the version of the the type of operating system on which you want to install this Weka tool. So I'm using Windows, so I just click here, and if you using Mac OS or Linux, so you can choose your appropriate type of operating system. So I'm just click here in order to download this Weka software. So it automatically started to download this software. It's working. Yes, it's downloading. So after downloading, you just go to your downloads folder and double click on the exe file of the Weka software. It's 3.8.4 version of the Weka software. So it asks you for permission to install this Weka tool on your Windows, so just click yes and then simply click on next, read the license of agreement and click on I agree, next. This is the destination folder. You can choose for your own choice, so I just simply keep it on the same destination folder without any changes. So do you want to create the shortcut? No, I do not. So after you finished installation, just click on next and finish. Before you start the program, just go into C drive, then program files and select the Weka 3.8.4 folder, and here you can see the folder naming the data. It contains different datasets, sample datasets for the Weka software. I'm just copying it and want to paste it in a separate place of my own choice so that I can easily go to that folder. I just want to rename its Weka datasets. So now just simply press on Windows button and click Weka 3.8.0. It's by Weka environment for knowledge analysis, and short form is WEKA, Weka. So it has 5 different applications like Explorer, Experimenter, Knowledge Flow, Workbench, and Simple CLI, command line interface. Experimenter is used for comparison of performances. Knowledge Flow is the actual graphical interface of the Weka version, and Workbench, similarly Simple CLI, is the command line interface or command line version of the Weka. So we just go into the Explorer and you can see it has 4 5 different panels or tabs. Like first one is pre-process, second classifier, clustering, association rules, and associate or attribute selection panel, and then visualization tab or panel. So here is the, if you want to open up a file or dataset, you simply click on open file, go to the folder where your datasets are available. So it's on desktop and in datasets. In datasets I have a folder of Weka datasets. So from this I am going to choose the weather nominal.arf. ARF means attribute format relation file format. Attribute relation file format. So here you can see this is weather symbolic relationship or relation. It has 5 attributes and 14 instances, and here you can see the 5 attributes of the weather datasets. First one is Outlook, and it has 3 different instances, which is sunny, overcast, and rainy. Sunny, 5 instances of sunny, 4 instances of overcast, and 5 instances of rainy. Similarly for temperature, humidity, windy, and play. Play is the class of the dataset or target variable or output variable. So in association rules we can ignore this, or you can use, it's your choice. So after using the dataset, selecting the dataset, you simply go into the association rule tab. Here you can choose from different association methods. Here we have only a priori and filtered associator, and FP-Growth is not available. I think in this it's available. So you can use these. So first of all, I am going to use a priori algorithm, and just click on start. That's it. So we go into the at the top, its scheme is Weka associations, and in associations we are using a priori algorithm, and these are all the default parameters of a priori algorithm. And in relation, you can see it is a weather dataset or weather relation, and similarly you can see it has 14 instances with 5 attributes. These 5 attributes are outlook, temperature, humidity, windy, and play. Either the you can play or not, given these the different parameters of the day. So when we apply a priori algorithm, in a priori algorithm the default parameters you can see here, the minimum sport is set to 0.15, and which is 2 instances. If you calculate, this is actually the if you recall the concepts of relative sport and absolute sport, this is relative sport, and this is 2 means the absolute sport. So that means anything or any instant that occurs twice in the dataset is frequent. So as you can see, this dataset contains, as you can see, 14 instances. So if you multiply by 14 with 0.15, you get the absolute sport. Or if you divide 2 by the total number of instances, you get the relative sport. These are the concepts that we had discussed in our very first lecture of association rule mining. Then we have chosen the minimum metric or performance evaluator measure. So in this case we have used the confidence as the pattern evaluation measure, and we set the minimum metric value to 0.9 or 90%. Similarly, the number of cycles performed by the a priori algorithm is 17, means these rules are generated in 17 cycles or 17 scans of the database. Similarly, next, the a priori algorithm generated different frequent item sets. So the size of set of large item sets L1 is 12. So this L1 is the frequent item set of length 1. So this algorithm generated or mined 12 item sets of length 1. Similarly, a priori algorithm generated 47 frequent item sets of length 2. Similarly, 39 frequent item sets of length 3 and 6 frequent item sets of length 4. Then using these frequent item sets, it has generated 10 association rules. That means the first rule is, if outlook is equal to overcast, implies play is equal to yes. That means if the outlook is overcast, then you can choose to play. So here is the confidence which is 1, or in other words 100. So if you can see outlook is equal to overcast, and here is the value 4, implies play is equal to yes, which is 4 instances, and the confidence is 1. Similarly, you can see here and other matrices also, like lift, whose value is 1.56, and similarly there are some other performance evaluation matrices. So how this one comes, confidence of 1 comes, and how this 4 comes and this 4 comes. So actually in the dataset we have 4 instances of overcast in which play of yes also occurs, and play of yes also has 4 instances. So that's why this is 1. So if you recall the concepts of how can we calculate the the confidence of a rule, which is if A implies B, if we have A implies B, then confidence is the sport of both A union B divided by the sport of left hand side of the rule or premises of the rule. So in this case we have sport of A. So as you can see in this table, in this rules, that as we can see in the nominator sport of A and B, in this case we have outlook and play is equal to yes, outlook is equal to overcast and play is equal to yes, the sport of these two together, which is 4. That means play is equal to yes and outlook is equal to forecast, outlook is equal to overcast occurs 4 times in our data set. So that's why it becomes 4. And you can see here outlook is equal to overcast occurs 4 times in this data set, so that's why it's 4. So that's why it becomes 1 or 100%. So that's why the confidence is 1. Similarly, if we can look at another rule, like if we talk about the rule number 8. So if you look at the rule number 8, which is if temperature is equal to cool and play is yes, and then implies humidity is equal to normal. So the temperature is cool and play of yes has 3 instances in this data set, and similarly the humidity is normal also have 3 instances. So that's why the union of the sport of union of both left and right hand side of the 8th rule is 3, and the sport of the right hand side is also 3. So 3 divided by 3 gives us a confidence of 1. So as you know, we had set the confidence value to 0.9. That's why it gives us the association rules of almost every rule is of 100% or the confidence of 1. So just let's do some changes in the parameters of the a priori algorithm. Like you can go click on more to know how it works and what different values or parameters indicate. Like here you can see output item set. It enables the item sets are output as well. Car means if enabled class association rule are mined instead of general association rules, do not check capabilities, and similarly you can search for all the descriptions of the parameters. So let's just do some changes in the parameters of the a priori algorithm. So this car means class variable is activated or not. That means can we want to make associations with our class variable, or can we simply generate the association rules on all the attributes by considering all the attributes together, or we can actually specify the associations of different attributes with our class variable, So if we want to make associations of different attributes with our class variable, then we simply click on choose this variable as true. So just click on OK and start this algorithm again. So you can see here the algorithm may generate association rules, associations of different attributes with the, here we have only the attribute play, which is our class attribute. Outlook is our cost, implies play. Similarly, all other rules we had association of different attributes with our class attribute. So similarly, if we can go and click on this attribute and convert it to false, and then OK, and click on start. So then you can see in this case it is a generalized set of rules in which we have mixture of the attributes and their association between each other. Another feature of this rule is here you can see we have the only the number of the frequent item sets. So we can have a choice that you can set if you want to output the frequent item sets. So then you can go into the attributes of the a priori algorithm and click on output item sets and select true and click on OK, and then just click on start, and it generates all the the frequent item sets. So it produces 12 frequent item sets of length 1. That means outlook is equal to sunny is frequent item set, and it has a spot count of 5. Outlook is equal to overcast, it has a spot count of 4, and similarly for other attributes, other values or attribute frequent item sets. Similarly for attributes of length frequent item sets of length 2, it generated the two item sets with their spot count, like outlook is equal to sunny and temperature is equal to hot occurs 2 times in the data set, and similarly for other 46 item sets. And you can see here frequent item sets of length 3, frequent item sets of length 6, and then we have the following association rules. Similarly, you can I'm just clicking on false to just simplify our view. So you can here we have delta variable, which is the gives or reduces the spot threshold value, starts from 100 and then by 5% it reduces, and in first iteration it sets the value of minimum spot to 100%, then to 95% on second iteration, and then third iteration it sets the value of minimum spot to 90%, and so on. And here is the lower bound minimum spot, which is 0.1. 0.1 means 10%, which is quite low. So I'm just going to increase the minimum spot to 0.3% or 30%. And here is a metric type, which is confidence. Now we had set the performance evaluator as a confidence as a performance evaluator. You can choose lift, conviction, and other as well. So I'm just using the confidence, and the minimum metric value or minimum confidence value is 0.9. You can see here we have generated all the rules with confidence of 1 or 100%. So because it has minimum metric value or confidence value is 9, so I'm just going to set it to 0.7 or 70%. Here you can see number of rules, how many number of rules you want to generate. Here you can see we had generated 10 rules in our previous executions of the a priori algorithm. So I am just going to set the number of rules to 5, or you can to or 9. Okay. output item sets we have already discussed. Remove all missing columns. Missing columns अगर हैं आपके data set में तो आप उसको करना चाहते हैं तो कर दें, otherwise no. Significance level, similarly you can check for other, you know, the variable upper bound minimum support is 0.1 or 100%. As we have already discussed that it starts from 100% and then decrease by 5% on every iteration, and the lower bound is 0.3% in this case. I just click on OK and restart or start the algorithm again. So here you can see we have a support of 0.7 or 70%, and its cycles perform 12, L1 12, frequent item sets of length 2, 9, frequent item set of length 3 is 1. Here we have rules of 1, 1.8. You can see here we have a rule of a confidence value of 0.86, 86 or 80% and 75% also in this case, because we have set the minimum metric confidence value to 0.7% or 70%. So this rule says if play is equal to no, then humidity is equal to high has a confidence of 0.4%. So if you divide the 4 by 5, which gives us 0.8, and let me check, 4 divided by 5 is 0.8%. Yes, that's true. Okay, I hope you have understand the working of the association rules. How can you use different data sets to apply association rules in Weka data mining tool. So I'll post a data set in Google Classroom, and you have to apply association rules on that data set in Weka data mining tool. Okay, so that's it. Thank you.